Okay, so today I cover the transformation examples of the Spark. Okay, so basic transformation. So yesterday I told about the setup in the PyCharm, okay, in Ubuntu. So once your PyCharm setup is done, then you can import the project. Okay. So same project we take it, and I will show the joins also, windowing function also. So I will show you all those, how to use the windowing function and other transformation functions like map, flat map, filter, okay, group by aggregations, right? So how can we do? Start my Python. Someone wants to do practice for the Scala. So Scala also same transformations we can use either Spark Scala or PySpark. So you can decide which one you want to do or both you want to do. Okay, so both are the different projects. If you want to use the Spark Scala, so you use the IntelliJ. If you are going to use the PyCharm, so you are using a PySpark project. Okay, so you decide what you want to use. So accordingly, so but in the interview point of view, both are important. Because some companies they are looking only for Scala, and some companies they are looking only PySpark, and some companies they prefer both because they don't know in which language they may have to use the either Scala or Python. So the basic fundamental knowledge is needed in both. Okay, like at least you can understand code of the Scala as well, right? What are the Scala features are there, right? The Scala programming features and how to use a Scala in Spark, right? How can we use? So basic syntax, if you know, then you can write most of the code you can write your own, right? You will not get any difficulty writing the code. Okay, because the library functions will be the same name. The only difference will come in writing the syntax, right? So when you are writing a Python, so Python syntax library API you are using, okay, Python syntax you are following, or when you are writing a Scala, so Scala syntax coding you are following. Okay. So we are writing the, okay, so when we are talking about the modules like in the Spark, right? So we have uh, 5 different modules are there, but mostly the data engineering we use the 3, right? We are using either Spark Core, Spark SQL, and Spark Streaming, and other two are one is a Spark Graph and a Spark like one is a Spark Graph and a Spark MLlib. So these two other two, like Spark Graph and Spark MLlib, are mostly when on demand, right? So if something is really needed, like machine learning related project, then we go for the Spark MLlib. So Spark Core is a base where we use all the transformations and actions, transformation and actions we will be using. And apart from that, transformation and actions and Spark SQL, we are doing integration of the different sources of the databases, data sources. So integration of the data sources. And these data sources are the file system data source and SQL data source like MySQL, Oracle you want to connect. So file system, SQL data source, file system data source, or NoSQL data source or NoSQL data source. There are the various different source system categories are there. And in the Spark SQL, we write the data also in the different targets. So these different targets could be the same. Okay. So you can write file system targets. Okay. You can have SQL data targets. Okay. And NoSQL data targets. So when you are writing a ETL pipeline in the Spark, so you will be defining what type of source and what type of target you are writing the data. So Spark SQL is completely on the data sources and data targets. Okay. And when we come to the streaming, so Spark streaming is basically for the real-time data. So Spark SQL is a batch processing data. This is for batch. So batch processing is the historical data. Okay. So when I compare with the MapReduce, so MapReduce is all only batch processing, not the real time. But the Spark is both batch processing as well as real time. So when we are working with the Spark, the Spark can handle the both type of data, batch processing as well as real time streaming. So this real time streaming is the data which is coming from streaming sources, which is coming from streaming sources. And these streaming sources are like Twitter is the one streaming source, or some REST API also streaming source. So any streaming source, the data is coming. So we use the Kafka in middle, right, as a message broker tool to handle this streaming source data. Okay. And this is the real-time streaming data, So the real-time streaming data we are handling with the Spark streaming. Okay. So in the real-time streaming data, so I will tell about how many ways we can do the streaming data to handle. So there are the two ways. So real-time streaming, real-time streaming data, real-time streaming. Okay. And two types are there in the streaming. One is a D stream. Okay, that is called discrete streaming. Discrete streaming. Discrete streaming, and this is called sequence of RDD. So sequence of RDD means the data is coming in the form of sequence of RDD. Okay. So this is the one way, and second one is structured streaming. Structured streaming is a little advanced of the D stream, and this is called sequence of data frame. The sequence of data frame, and it is easier to handle as compared to RDD, right? We already know, right? Handling of the data, transformation of the data is easier in data frame rather than RDD. Because RDD is a row by row operation, and data frame is like column oriented manner, right? We perform the operation, right? Okay, so Spark is finished. So other two modules are there. One is the Spark ML Lib. So Spark ML Lib is a machine learning, and those who are having a machine learning project, so there we use the Spark machine learning libraries. So these Spark machine learning libraries are the on top of the Python machine learning, like APIs. We can use this. Spark ML Lib is a in-memory computation. So Spark, we are any module we are using, we are getting a Spark benefit. So either we are using a Spark SQL, core, streaming. So everywhere we are getting the Spark benefit. So this is a machine learning libraries of Spark provided. Okay. And the one more last module is the Spark graph. The Spark graph module is used where we have the data is connected, right? Like I say, vertices or edges. Okay, it's like a graph form, vertices and edges. And mostly this type of requirement is there in the social media networks. So social media network where we have there this type of requirement where we have to find friends of friends, like, or we have to connect it, right? One person is connected to another person and we want to get the data. So this kind of data we can get in the social media. So our main concentration on these first three, because core is the base and SQL and streaming These are the two different categories of the data handling, batch and streaming. Okay. So when we come to the core is completely transformations and actions. So yesterday I told about there are the three data structures are there in the Spark. One is RDD, data frame, and data set. Okay. So people ask about the differences, right? What is RDD? What is data frame? So RDD is it's an immutable collection of the data, which is spread across the worker executors. And RDD is immutable collection, right? It is like it cannot be like you can create a new RDD, but you cannot existing RDD you cannot modify. So RDD is maintaining. Here is a one concept is there DAG, direct acyclic graph. So what is direct acyclic graph? So direct acyclic graph is basically keep maintaining of all the operation in your RDDs, right? You're keeping in a graph form. So whenever like your RDD got failed, it can recompute. Okay. So that is the concept of DAG. Okay. So RDD is basically immutable collection of data, and data frame is a enhancement in the RDD that is providing tabular representation of the data. So tabular representation data, right, in the form of row and column. So tabular representation of the data in form of row and column. So row or column means here, like we call it table. So we know, right, table has the records and table records and table has fields like columns, right? So data frame is providing the data in the form of row and column. And data set is for the extension of RDD and data frame. Okay. So extension of RDD and data frame. And data set is providing right encoder as well as it's a like type safe, okay, compile time safe, right, and strict type API. Okay, so like these are the key features of the data set, but mostly we use RDDs and data frame. So RDD we use for the unstructured data, and data frame we for use structured data. Okay, or semi-structured data. So purely unstructured data means like data is not in the structured form, like text file data. So any text file data is basically unstructured data, and we call it like RDD is the form of the data we reading. But when we are reading any schema-based data, right, I'm reading a data of the CSV, JSON file, XML file, Parquet file, or any SQL database data. So these all data is getting data frame. So directly you get a data frame of out of the data of your these type of sources. Okay. So when we come to the transformation, so we start the transformation. So first, like how many ways we can create RDD? This question comes, RDD is like how many ways we can create RDD? Okay, so one way of RDD is we can use a parallelize function. So parallelize function is like you can pass any collection, and then this collection, whatever collection like list, set, okay. So when you pass any collection, you will get RDD. So RDD equal to parallelize dot spark context dot parallelize. If you call function like this, so your collection will become, this will be a normal collection, and after applying the parallelize, it will be distributed. And once your collection is distributed and parallelized, then it will become RDD. So RDD means it's Spark fundamental basically, and RDD means it's a distributed immutable collection, and which is spread across the worker executor, and then you can perform your transformation. Okay. So I can do normal transformation in collection in the Python collection also I can do the map transformation, flat map, filter is there. Same collections are there, same transformations are there in the Python. So what is the difference between Python language transformation and Spark transformation? So Spark transformations are distributed. Spark transformations are parallelized, as well as it is immutable, distributed, and it is in memory, right? So when you are using Python based transformations or Spark transformations, right? So you will be Python language transformations are the single threaded. It will not be giving you the advantage of the in-memory computation. So whenever we are saying map, flat map, filter, okay. So these transformation, reduce by key, group by key. So these are the transformation are the Spark in-memory computation will be using. Okay. Group by key. Okay, reduce by key. So these are the, and Python transformation also there, right? Same transformations are there, Python, okay. But for the small data, if data is not very large, you can go for Python. See, why we need Spark? If already everything is given by the Python, so Spark is providing a distributed computing, right? And like parallelization, and when your data is distributed across the cluster, so then your data will be transformed and applied transformation. So all these things we are doing through the Spark. So Spark is taking care of that part. Okay. But when you are using Python, so everything you have to do manually, because here Spark is taking care of that distributed part. And if you want to do, you have to handle the distribution, but you will not get that much refined, that much is there in the Spark. The parallel, the speed and all those things, you will not get it right in memory computation. Okay. So first we have to do how to create RDD. So one way is creating RDD by using the parallelize. Second way of RDD we can create through, we can read a file data. Read a file data, we can get a RDD. I said read a file data, like any unstructured data file. Unstructured data file means text file, any text file. Okay. So any text file data which is not uniform data, right? Like basically the data is completely. So this kind of data is unstructured data, where is no fixed number of columns are there. So this kind of data you are reading in Spark, so then you will get RDD. You will get RDD. So this is the second way to get RDD. And the third way and final way of getting RDD is like one RDD to get another RDD. So when we apply transformation, then you get a new RDD. You can get new RDD. So that is the third way to get RDD. So one way you are apply parallelize functions. Second one, you are reading a file and get RDD. And third one is you are getting the through one RDD to another RDD. Okay. So ideally you look at two are the common ways, but third one is just any like once you get one RDD, then you can definitely get the second RDD when you apply transform. Okay. So I will show you one example. Suppose I have a data in my file, how I can do the word count in the file. Okay. So how many ways you can run the PySpark code? You can either run in PyCharm ID, you can run the code, or you can start the PySpark shell. So just you write a PySpark and you will get a PySpark shell. And this PySpark shell, you can write your code, right? So this is an interactive shell. So you write syntax, right? You write a code and then you can get the result immediately. And the second one way is you can write in PyCharm ID. Here you can write the PySpark code. And the third one is you can write a Python file and you can do the Spark submit job in the cluster. So that is the third way to get the same result. So result will be the same. So one is the PySpark shell, that is an interactive shell, and it is a one by one statement. It cannot run the entire program in a one go. So it is a step-by-step writing code, right? Like you write in the Python shell, same right you are writing here, the PySpark shell. So this PySpark shell is using your Python code, and this PySpark shell, you can do whatever you can do in the editor, the same thing you can do here. Okay, but here in PyCharm editor, you have to create your Spark session manually, because by default you will not get the Spark session. But in case of in the PySpark shell, you will have directly get the Spark session, because when your PySpark shell comes and you type Spark, so you will get Spark session will be by default is available. Okay, so you don't need to create a Spark session. So if you see Spark, you type, this is a Spark session type. So whatever file you want to read, suppose you say rdd equal to, you say spark dot read dot text, and then you give some file location. So I want to read some file. I say file colon triple slash. So I'm going to read a local file or Hadoop file system file. So if you start your Spark shell, so there is a, how I write a Spark here, PySpark I written. If you write PySpark and hyphen hyphen, you give master. If you are giving master yarn, so your PySpark shell will be starting in the yarn mode, and it will be reading a file data. Okay, so if you that line is okay, if you write it here PySpark, and then after that you write hyphen hyphen master yarn, so your Spark shell will be going to read data from the Hadoop file system file. Otherwise, it will be reading the files from the local. So for local file, you have to give file colon triple slash and my home directory. So I can give any file, whatever my home directory file. So just let it see. I'm just taking up some text file example, so I can show you the transformation. Okay, let's see this XYZ example. So this XYZ file in my home directory. Okay, so I'm going to read this file. I say my home Arvind and XYZ is a file. Okay, so there is no extension. I'm not giving any extension. So once I do this statement, this spark.read.text, actually it will not read already, it will read a data frame. So spark context.text file method is there. So if I see rdd.show I do, actually data frame method is a show. So whenever you do spark.read.csv, spark.read.json, spark.read.parquet, so it will get a data frame. So this text file data, even it is unstructured data, but I am reading as a data frame. If you see 20 line is showing, by default is showing 20 line. If I want to see this complete line, actually there is a property truncate equal to, we have to something I given wrong. Maybe to give first part is a number. By default, truncate equal to pass. This one we have to give. Test number. Sure. Thing I was giving in the capital T. Okay, so if you see, this is the data, the default is a 20 rows, but if I want more than 20 rows, I can give here the number. Okay, I will give like 100. So I will get 100 rows data. Okay, so this is 100 rows data. So when I do the read dot text, so this is reading as a data frame. So entire file data is coming in a one single column. Okay, so if I want to see how many rows are there, so this is a data frame. So when I do count function, So it will give me the number of total rows in my this data frame. Okay, this is not RDD. Okay, so 36,625 rows are there. Okay, so this count is a action. Count is a action. So when I do count, it's a action. It's giving me the final result. Okay, I want to read this data as a RDD. Okay, not as a data frame. So I'm going to read a file. So there is a way spark context and spark context dot text file. The text file method is giving you the RDD. This is the RDD. Okay. The transformation actions are common. Okay, but different ways. So RDD dot count. Okay. So now, how can I say this is the RDD? If I try here RDD dot show, so now it is not able to get it, right? Because it's not a data frame, it's a RDD, right? Okay, so RDD dot collect is there. RDD has the collect action. So RDD dot collect. So it will be collecting the result. Like, see, this is entire because so I'm getting this entire result as a RDD, as a list of data. So if you see in the square bracket, it is coming, each value is coming, is a RDD result. Okay. So this is like collect. So if I want to do some transformations, like, okay, I want to do this RDD result, I want to do like word count I do. Like I say, these words are repeated. Okay. So first of all, on the RDD, I will apply the flat map. Flat map I do, and I say, because this is the Python code, I will use the lambda, and I say lambda x, I say each line I will pick and I will split it, x dot split, and I will do in the double quote space. I will split it out, my entire lines, all the lines I will split it and get a single array. Okay, now I will do collect. So what I will get it. Flat map is doing flattening. Can you see? It is all the lines what it is giving me in a single array, right? So suppose I say one line has some set of data, second line has some set of data. So it is collecting all the lines data and creating a word. So you can see flat map is doing flattening and it is collecting all the data in a single array, right? Now, whatever I did, I don't apply the collect, because whenever I do collect means it is calling my action and it will be performing transformation. Now I'm doing not collect, I'm doing another transformation. I say, first I do flat map. The second one I want to do the map, and map I want to say lambda, each word I take it, like each element I take it in this array. What I want to do, I want to say x comma 1. X comma 1 is like I want to say every word is 1 count I gave. Okay, and after that I do collect. So what will happen after this collect? I will get every word is 1 count will come, right? Okay. So you remember, right, in the map reduce we used to do this, right? Right, we used to do in the map function, we giving each word is a 1 count. So here, what I did the transformation means conversion, right? Like one form to another form. So if you see here, before this map transformation, what flat map transformation did, it bring all the data in a single array. And what map transformation did, it give each word is a 1 count. Now the next transformation, I don't call the collect and I do reduce by key. So reduce by key is the another transformation. And here you use a lambda, and here you need a two property, x comma y. Okay, and you have to do the sum x plus y. So what you mean to say, like I say, if this Nigeria is coming 10,000 times, so it will make it Nigeria comma 1 plus 1 plus 1, 1 plus 1, 10,000 times. So my total value of the Nigeria will become 10,000, right? So this is my actual word count. Generally, I do the word count like this. If one word is China is coming only 10 times. So what should be the total value of the China? 10, right? So 1 plus 1 plus 1, 10. So this reduced by key is based on the key. It will aggregate your value. Okay. So based on the key, reduced by key, it will aggregate the value of your key, right? So after this, you do collect what you will get it. So every time I'm calling the action, okay? Once my transformation, so all transformations will be lazy here, right? Until unless you don't call the action, your transformation will not trigger. So when you call action, then your transformation will trigger, right? So here, how many transformations are there? 3 transformation, flat map, map, and reduce by key. And how many actions are here? Only one, collect. Okay. So total number of words are these only. It is 36 times 36,000 words are there, but how many repeated words? If you see, China is 18, 13, 1, 2. Same number of times, this, all same time. But some space word is there also. So that is also having the count 9156. So I say this space I don't want. I want to do filter in my this space count. Okay. So this is final word count has come, but still I want to say, okay, I want the word which is starting with I. So how many word will come? Okay, I will say India will come, Iran will come, or Indonesia will come. Okay, so these kind of filter things you can do, or you say, okay, how to apply filter? So entire thing you have to do. Suppose this thing you want to store some variable, so you can take it in another RDD. Okay, just take this result to another RDD, say RDD1. So once your result is stored in this RDD1, now this RDD1, the entire thing is stored in your RDD1. Now RDD1 dot, I say filter. So again, you have to use the lambda. So lambda x, what you will say? Can you tell me, like, suppose I want to do, I don't want to space one. X not equal to space. So I'm saying lambda x colon x not equal to space. So those I want to filter out. So actually I have to use the single quote because double quote is already there. So I have to use here single quote, and then double quote is your my this. And then I will do select. Str object is not callable. Contains is the function. Okay, so we are doing the already. Okay. Addition there, we will take is in, is in, right? Something is, but this is for the data frame. Okay. Okay, first we do the contains one. Okay, so contains is, I say I want to contains. Okay, okay, this is not string type. The string type values we can do the transformation. Already. These are the RDD's transformations. So flat map, I showed you lambda x dot split. Okay, like map is x comma 1, right? And reduce by key lambda a comma b colon a plus b. Sort by key, like you can do the sorting right on the key or value, right? You can do. Filter is, okay, so you have to do like a in x of 1. So like this, like x of 1 is basically is a particular array index position, right? So I say for each value I will be doing, okay. So this type of transformation you can say. So I have to say I in my x of 1. Okay, so I say not like this. Single quote I. Which RDD we are doing? They are doing when I'm doing Okay, this is in the key value pair. X of 1, this is 0, this is 1. Okay. So our key value pair, what type it is then? So I do collect okay. So what should I do?
Guys,
We should do on the
Mhm.
so if we do on the 0, so 0, there key is x of 0, x of 1 and x of 0. X of 1 is this key value pair. Two and this one that has value a. It should be one iteration type str of that is okay. So this one is not filtering. If we are able to see the word count. So once we filter it, right, we can find the word count, right? And this we can write into the file also. We can write any article into the some text file and I can write the data. So same thing I can do with the data frame also. We can create, this is the way is we are applying on the RDD, right? We can do the simple word count, like different transformation function. So there are the other transformations are there, like union transformation is there, intersection is there, and we have the other transformation joins are there, like how to join the two RDDs, how to left join, right join. So we can perform any number of transformation. So if you have seen the list of transformation in RDD, so these are the transformations like union, intersections, and map partitions and distinct, right? I want to find the distinct value in the RDD and repartition and coalesce. So these are basically for the reshuffling is doing, right? It is partition, right? Okay. So coalesce is always decreasing the number of partition, but repartition can increase or decrease depending on the number of partitions are there. So it will reshuffle the data. So generally these two functions for the improving the performance, right? Whenever we have less number of partitions, we can club together and make like instead of having a more partition with less data, we will make it less partition with more data. Okay. So that way we use the coalesce. Okay. And that is increasing the better performance. Okay. So these are the intersection we can do, union we can do. If you want to get the some sample data set, so we can use the uh, this sample data set we can find. Okay, map partitions, map, so flat map, filter. So we can apply this transformation on the RDD. So same thing if we want to do in the data frame, so we can apply on the data frame also, we can apply the transformation. Okay. So when we come to the data frame, so data frame we can we can convert from the RDD to data frame, right? One RDD we have and we can convert the data frame. So there is a 2DF function is there. So RDD to DF we can convert to data frame. And another way of creating data frame is we can provide a schema, right? So it is very easy, right? Like if I have some RDD I have, so when I use parallelize function, I can get the RDD. Okay, so suppose I have a one department, I have a list of departments I have as a tuple, list of tuple, and this tuple I'm passing, this list of tuple I'm passing in my parallelize, so it will become now RDD. Okay, so when I do here, when I just pass this my tuple to parallelize function, so now my RDD is like parallelize. Okay, now I will do all these transformation things I can do count. So count is the action we can call action. So there are the four values are there, four record. So I'm getting the four. Okay. So I can do map, flat map, filter, all these things we can do. So next I want to just change it to the data frame. So what I do, I make it RDD to DF. So right now it's coming as a list of tuple. But when I apply as a 2DF, it will become a tabular representation of the data. So now when I do this DF and when I print the DF dot show, so I will get the two columns. So my data is distributed into two columns. Like one column is this, but here is name is not coming. But when I want to convert with the name, so simply what I need to do, I will pass the column name also. So I say here DPT, okay, DPT name, some name I'm giving and DPT ID. Okay. So like this I am doing. Later I can change the column. Okay, okay, like this I have to pass the index. So this is the way. Usually in the Scala and Python, this is the difference. We have to provide as a list type of columns. So I cannot pass as a string type. I pass as a list. So now it will find. So I'm getting a two columns. So in my data frame, two columns are there, DPT name and DPT ID. Here is very easy to apply the filter. If I say df2 dot filter and I say I want to filter only DPT ID greater than 10. So DPT ID greater than 10 dot show. Okay. So I will get 20, 30, 40. So here directly you are applying on the column basis, right? You know, RDD in the filter is row by row. But here, suppose I say I want to do DPT, some filter I want to do DPT name. So DPT name dot contains, we say that contains function. So there is a it is not instance of declaring class. Filter I want to do either filter clause and where both are same filter and where clause. So how many types of filter we can do? How many ways? Filter you can check the value directly equal or filter with the simple condition not equal to like this and condition filter based on the list values are there is in basically if we have some list of values. So I don't need to give in the double quote. So df dot column dot is in, and then I can give the list. I df2 dot I pass it the list type values. So what are the values are there? So 10 and 20. Suppose I want to get only two 10, 20 is in. bracket you have to close here before show. So this 1020 is a bracket for the is in. Okay. So when you do is in means only 1020. So only two departments, right? 1020. So like this, you can apply the filter conditions. Okay. So try it out, like some of this filters or map, left map. So here also in the data frame, you can see the example. Okay. These sort of examples are there, and complete this code also you can run entire code, because this code is having the data. So if you copy this code and this entire code, you can test it here also one by one, because I'm running all the statement one. So you can check your, because here is the data is there, right? So df.show, this is a print schema. It is showing the schema because this is the showing your name column, language column. It's an array type column. Okay. And this is a struct type column, right? Okay. And you are doing filter on the gender, male, right? So male data, only male is coming, right? You are doing the df.language contains. So contains is array contains is you are checking which value matching with the Java, right? So only that where the Java is matching, only those rows are coming. And this one is matching with the last name. So df.name.last name. So last name is this Williams, right? So this value is matching. So here in the df.filter, we are giving again df.column name. Okay. And then whatever condition is there, so we are giving the condition. So you can test it this kind of code, and then you can understand how this filter is applied different ways, like on the array values, how to filter. If any object type values are there, how to filter, or in single value is there, how to filter. So there are three types of conditions. If single value is there, so df.gender you can directly use. Okay. df.gender equal to m. So df.gender, or directly gender also fine, but double quote. Okay. Or otherwise df.gender without double quote. Or if your value is an array type, so array type value is there, you can use contains, right? So there is the array contains is there. If you have seen here, array contains. So array contains function you can apply on the language column, and then you can check which value you want to get the record. So only that value having the data, it will come. If you have some object type values are there, so you can use like dot function. So df.name dot. So we have in the schema, this is the first name, last name, middle name. So I'm checking it here, last name, like last name, df.name dot last name. So this last name, I'm just checking where is this value. So this way you can do the filter conditions. Okay. So try it out on RDD and data frame, this transformations. Okay. Okay. Anyone has any question? Okay. So tomorrow anyone wants to attend session, so I will do. Yes, tomorrow morning.
Oh, tomorrow what time?
Tomorrow 9 EST, 9:30 EST.
Oh,
Or we can do on the Tuesday. Tuesday we can do. Okay. Yeah. Okay. Let's see tomorrow if anyone join. Like then we will do. Okay.
Yeah, tomorrow I will join.
Okay. Okay, Arvind.